Yeah. Hi, my name is Nishant Sharma. I am part of the query processing team in Greenplum database, VMware. So through this video, I would like to share how direct dispatch works in Orca, which is a query optimizer in the Greenplum database. So I would like to start with a overview on the Greenplum database, which is a massively parallel processing system. So here we have a master node, or we can say it as a coordinator. The client interacts with this node only. The user data is distributed across the segment, and the query comes to the master node. It generates the plan for it and sends the data to the different segments for execution. Now, since we have distributed the data across the segments, so we can use this to get the data back also. Now we know using what policy we distributed the data. So here lies the concept of direct dispatch. If we know that our data is there in at segment 1 only, so we need not to waste our resources of other segments to check if that data lies with them. We can directly send the plan to say segment 1 and get our data. So let us first see what are the different types of data distribution policies we have. So one is hash distribution and the other one is a random distribution. So in both of these cases, we'll see how direct dispatch works. So we'll start with the hash distributed tables. To define a hash distributed table, we have to write a query like create table foo, where we have the columns and distributed by which column. So we say ID here. So now assume this is our sample data. And if we say our hash function is say modulo 3, so we'll compute the hash value of this distribution column, that is ID in our case. And the tuples will be distributed across the segments. And it's like tuples with the same value, hash value will be co-located. Say this could be one of the distribution if we have hash function as modulo 3. Now let us see one query. If we write the query like select star from few, that means we want all the data from across the segments. So this is the plan which got generated for this query. So we see here that the query, we got the data from all the three segments. So the plan was sent to all the three segments and we gathered at the master or coordinator node this data. Now, what if we can have in the query itself, we can have the information that where our data lies. Say if the query is like select star from foo, where the ID is 2. Now that we have distributed this table with the column ID, so we know where would this ID2 data be lying. So we can directly send this plan or to that segment and get our data. So here we can see we are gathering our data from one segment only. So this query did not went to all the segments. So only we get the data from one segment. Now let us see what happens in random distributed tables. So here the tuples are placed across the segments in a round robin fashion. So no hash value is computed. To define such a table, we can write the query as a create table bar with the columns and distribute it randomly. So in this case, for this our sample data, in round robin fashion, we can distribute it. So if we write a query like select star from bar where ID is 2. Now, since we did not hash the data with this ID, so this will be sent to all the segments and we all have to find if there is any tuple with ID equals to 2. So, and all will respond. So it went to all the three segments. But if we write the query like uh, select star from bar where we are specifying the segment from which we want the data, then in this case we can directly send it to that segment and get our data, say where segment ID is 1. So we can note in the plan only one segment had to respond in this case. So now I have created, I would like to give a demo where we can see on the terminal what are the different output for different queries. So I created some sample data for it. So I've created a table foo, uh, uh, which is hash distributed and has data from 1 to 10 in the ID and multiplied by 10 in the value. And so this is a small table with 10 tuples only. Then I created one big table with the 100 million tuples. And I also have a randomly distributed table bar with 10 tuples and a big table with the 100 million tuples. In Orca, we have some gugs. These are kind of knobs which can be used to enable or disable a feature. Say if you want to, so we will be using it to see what impact does this direct dispatch have on the queries. So we'll start with our first query for a hash distributed table where we just want to see what data do we have. So here we can see in table foo, we have it is distributed across 3 segments and segment ID 0 holds to 4378 ID and similarly the other segment hold the data. So we'll keep this as a reference and see what output do we have. So in the next query, say if we write, we want the GP segment ID and all the data from foo, where ID is either 2 or 7. So if we see the plan, we are getting this data only from one of the segment. And if we note here that ID 2 and ID 7 lies on only on segment ID 1. So we'll just see the response. So what is the output? So here we can see only segment ID 0 responded and 2 and 7 we got the output. Similarly, we can write a query for disjunction case where we want the data where ID is 2 or 4. Oh, sorry, I'll correct the query. So here we can see ID is 2 or 4. So ID 2 and 4 lies on segment 0 only. So it is directly dispatched to that segment and we get the data. We'll try one more query with where we are specifying the GP segment ID and we are giving one more predicate on ID that it should be between 1 and 10. Let us see what happens in this case. Now that we have specified that ID should be 0. So from GP segment ID 0, we'll get all the data which is between 1 and 10. We can see the output for this query. Here we can see we got this 24378. So 24378, we got the output. Now let us see, let us compare the execution times in case of a very big table. Say we send this query to a table with 100 million tuples and we want the data with ID equals to 2 or 4. So let us execute this query. So since the table, so here we see it took almost 5 milliseconds and since like 2 or 4 are lying on the same segment, so it went to that segment only. It was directly dispatched and the execution time was almost 5 milliseconds. Now if we disable direct dispatch, then let us see what is the output in this case. How much time does it take? So now in this case, the query won't be like dispatched to a single segment. So it will be dispatched to all the 3 segments. So here we can see it went to all the 3 segments and we can see it took 400 milliseconds more to execute. So here lies one of the benefit that we save some time on execution. So we'll put the gug back on again. I'll just clean the space. Now we'll see what are examples for hash distributed table. So first, let us see what data do we have. Oh, Okay, so this time we have to see for the random distributed table. I clean it. So in random distributed table, we see that segment 1 and 2 has only one tuple. And now let us run our sample queries here and see. So here we are specifying if segment ID is 1 or 2. So it should directly dispatch to these segments only. So yes, it went to 2 segments only, and we can see the output here. What is the output? So we get data from segment 2 and segment 1. So we can also write a query like this, where we want all the data from the table where say the value is less than 70, but we want from segment ID 0 and 2 only. So it should be directly dispatched to those two because we are specifying from which segment we want that data. And if we want, we can also see the result. So here we have only data from segment ID 0 and segment ID 2. So similarly here, I would like to also compare the execution times in a big table, say 100 million tuples if we have, and we are specifying the segment ID. So let us see how much time does it take. So it took almost 6 milliseconds. So we'll turn this off. So now direct dispatch won't happen. And let us see how much time does it take in this case. So here we can see it's we saved some amount of time here, almost 100 milliseconds, give or take. So some time is saved in this case also. So I hope you got a fair bit of idea on what direct dispatch is and how it works. Thank you for your time, and